Hello there, children. It is I, Mr. E. I'm down in a deep, dark cave. Oh, wait, you see bricks. Yeah, I'm actually outside. It's a wonderful, amazing night. It's nice and cool. So let's do some word problems. How about that? All right, let's get rid of this. Goodbye. Okay, we're going to solve systems of equations. And this is how you're going to. Why are you up here? These are some questions that you might see on the STAR exam, actually, or maybe on our own tests. But this is how you would applications how you might use these things in the real world, or in STAR tests actually, because this first one um, just has tables. So take a look. The tables of ordered pairs. Ordered pairs. Oh, here I'm going to do this. Ordered pairs represent usually x and y, aren't they? Represent some points on the graphs of lines C and P. So here's a line, and I'm going to switch colors for this one. Here's a line. Now they've got these sideways going from left to right there. So x is on top and y is on the bottom. So let's take a look. Actually, it's bugging me. Let's take a look at line C. It says write the systems of equations represented by the lines. So we need to find the equations first. So the way we're going to do that is this. We are going to first find the slope. So we're going to look at the change. Look at the change. So this will be the change in y. This will be the change in x. And remember, the slope is the change in y over the change in x. So don't get mixed up because they put the y's on the bottom here. Anyway, change in y over the change in x, also known as the rise over the run, is, well, let's find out. Let's see. From 1 to 2, that's a plus 1. From 2 to 3, that's a plus 1. So it looks like we're going to have, oh no, oh, look at me, entered in the wrong spot. That's the run, because that's the change in x, so it's going to go on the bottom. And then let's see, what did we change here? From -1 to -6, we went down 5. -6 to -11, we went down 5. So this slope is -5. -5. Let me scooch that over so we can put it right above it. Save us some. All right. Well, now you can't see it. So that equals -5. That's the slope. I'll just put that on the end so you see. The slope, -5. That's what we're going to use. And we can pick a point to plug into point slope form, but I want to spend just a little bit, just one more step to save me from using that formula, because sometimes it's a little complicated. It's got parentheses and all. So I'm going to do this. I'm going to go backwards one step because I know, whoops, go backwards one step. Let me make my eraser bigger. That's not an eraser. Make it smaller, actually. So I am going to go backwards a step, and going this way, I'm going to go down. So this will be 0. That's not a pen, is it? This will be 0, 0. So the step before, so you see as you go down, you go 3, 2, 1, 0, right? So what's important about x being 0? Well, if I have x at 0, then the y value when x is 0 is our b. That's our b value. That's our y-intercept when x is 0. So I'm going to go backwards a step here, and that is going to give me, well, I'll be adding 5 when I go up, won't I? So that'll give me a positive 4. That's right. So 4 minus 5 is minus 1. Yeah. So the b value here is 4. So now I can put this equation in slope-intercept form. Y equals the slope, which is -5, times x plus 4. So here's my first equation. Now I know we're going to set it into, or actually we do. We need it in standard form to put it in a system equation because we're going to solve using elimination. So we just need to put that in standard form. Let's just put the x on the other side. So there we go. 5x plus y equals 4. There it is in standard form. There's our first equation. 5x plus y equals 4. Okay, let's do the next one. Let's use this blue here. Line P, I need to find this slope. Here we go. Each time we're going, let's see, from 3 to minus 2, we added 1. From minus 2 to minus 1, we added 1. So there's our change in x. Let's see, the slope here is going to be, that's the change in x, so it's going to be something over 1, so it's going to be a whole number as well. Let's see, from minus 16 to minus 14, that's up 2 plus 2 plus 2. So our slope here is 2. Now looky here. We can go up 1 more, and x will be 0. Let me put that actually right here. X will be 0 if I go up 1 more. Why is that so light? That's odd. So let's go up 2 more on the y. That'll be minus 10. So there's my b value. I'll put it down here. You can see b equals minus 10. So now I can write the blue line. I'll just keep on going over here. As this, y equals the slope, which is 2 times x, minus 10. And then I'll just subtract 2x to put it on the other side. So I have minus 2x plus y equals negative 10. But remember, we can't have a negative value for a. So I'm going to just change all the signs. 2x minus y equals 10. You can remember anything you do to one side of the equation, like change the signs, do to the other side. The long version of that is you multiply by negative 1, or you divide by negative 1, and that just changes the signs. So here's our second equation, 2x minus y equals 10. So now I'm going to solve my system of equations. Looky here. I have same coefficient, different signs. Perfect. It's already set up to eliminate. So that's going to go away. And then I just combine over here. 7x equals 14. That's kind of easy. Divide by 7. X equals 2. So find the solution. X. Right, like this. X, y equals 2, comma, something else. Let's see. Let's plug it back into the easy one here. Well, top one, that's fine. Let's see. 5 times x, which is 2, plus y equals 4. 5 times 2 is 10, plus y equals 4. Subtract that 10. So that gives me y equals minus 6. There we go. Y is minus 6. Here's my 2 answers. Let's verify the solution, shall we? We're going to plug both these values back into those equations. So the first equation is 5x plus y. So 5 and x is 2 plus y, which is minus 6, equals 4. That's this first one right here. Well, let's see. 5 times 2 is 10, and then a plus a minus 6. That's minus 6 equals 4. Well, that works. Sure does. All right, what's the next one? 2x, well, not x. 2 times 2, x is 2, minus minus 6 equals 10. All right, well, 2 times 2 is 4. This negative in front of this, I'm multiplying. This is really a 1. Remember? And so I'm multiplying a minus 1 times a minus 6, so that gives me a plus 6 equals 10. And yes, 10 equals 10. That checks out. All right, let's go over here. There are 15 plates in the kitchen cabinet. The diameter of each plate is either 7 inches or 12 inches. The total of all diameter measures is 140 inches. That's great. Okay, which system of equations can be used to find the number of 7-inch plates, which is x, and the number of 12-inch plates, which is y, that are in the cabinet? Okay, well, we just need to look at these down here, these 4 systems that they give us to choose from. So here's the first thing. Remember, first thing we're going to do is define a variable. So X is the 7-inch plates. So 7 is X. And the 12-inch plates are Y. And let's see, what am I going to do with those? Well, let's look at the first part here. There are 15 plates in the kitchen cabinet. This is a number. This is the number of plates. So this is a total, 15. And there's two kinds. They're either 7 inches or 12 inches. 7 inches was X. There. 12 inches was Y. So down here I can say X and Y, 7-inch plates plus 12-inch plates. Well, there are 15. So here's my first equation. X plus Y equals 15. So let's look at our choices, see if we can narrow some of these down. X plus Y is 140. No, 140 was the total of all the diameter measures. So if you measure the diameter of the plates, and that's like, if that's a plate, the diameter is the distance across the plate that goes through the center of a circle. So the diameter is this, and some of them are 7 inches and some of them are 12 inches. So there you go. So let's see, the number, no, not 140, so it's not going to be A. 7x plus 12y, no, we need an x plus y equals 15. Right here. Here's an x plus y is 15. So it might be C, but that's down here too. It might be D. All right, so we need to find out what we're going to do with these two, these left, the 7x and the 12y. Well, this is the diameter, right? This is the diameter. So the second equation is going to be about the measure of the plates. So we have the number of plates, there are 15 of them, and then the total measure, I'll put total measure, and total number of plates. Sure. So the total measure of the plates, if you measure them, that's a different number, right? It's 140 inches. So that's messy. 7x plus 12y is going to equal 140. So there's that. And then that'll tell us exactly which one we need to use. Let's see. 7x plus 12y equals 140. There it is. So it's C. Yeah, because the one down here, this is 12x, and 12 was with 7. Or I'm sorry, x was with 7. So it's not D. There we go. All right. Let's go down to the next one. A bag contains 18 coins. And looky here, that's just like the plates, isn't it? Let's use orange this time. 18 coins. This is the number of coins. I don't know why I spelled coins with a T. Well done. I'm a college graduate, folks. Number of coins. Bag contains 18 coins consisting of quarters and dimes. Oh, well, there's our first equation, isn't it? We've got 18 coins, and there's quarters and dimes. Let's call it Q and D. So I have quarters and dimes, and the total is 18. There's my first equation. Oh, look, and there it is right there. Might be that one. Quarters and dimes, 285. No, that's the total value of the coins. So the value of the coins is going to be in my next equation. Well, let's put the value of these coins with their variables there. What's the value of a quarter? That is 0.25 cents. What's the value of a dime? That's 0.10 times D. So that's going to be my second equation. 0.25 quarters. And it's not this. Quarters aren't 10 cents. Quarters are 25 cents. So, did not go through this. Oh, well, I went up there. Now we have both. It's not this one. That one's backwards. Here's a Q plus D is 18, and here's a 25 cents for quarters and a 10 cents for dimes equals 285. Probably that one. What's down here? Quarters and dimes, 25. Nope, not that one. It is C. All right. Let's see what we have on the next page here. All right, the graphs of line K sub 1 and K sub 2 are shown on the grid. Which system best represents, or which system of equations is best represented by this graph? Well, let's take a look. One way to identify, probably the best way to identify the graphs of lines, is to look at the y-axis and find their y-intercepts. For K sub 2, which I'm going to use this pink color here, that y-intercept looks like it's at, I covered it up, looks like it's at 4 there. 4. So let's write that down. The b value for the pink one is going to be 4. Let's see if we can't find the slope. Let's start here at the y-axis and count. It's kind of tough, but it does look like it crosses here at 9. That's going to be the x-intercept. Let's write y-intercept right there. And that's 0, 4. Okay, well, let's count 1, 2, 3, 4. So the rise is actually a fall, minus 4. Let's put this over here. This is the slope. The rise is minus 4. And then let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Y'all probably could have figured that out just by saying, hey, Mr. E, that's the x-intercept. It's 9, 0. So the run is a positive 9. So there's your slope, minus 4 over 9. That doesn't reduce, does it? So that is the slope. So we can say that the pink line, let's write it in slope-intercept form. It is y equals minus 4 over 9x plus 4. Let's see. Oh my, looky here. These are in standard form. Let's do a little work, shall we? I'm going to do the work down here where we have room, and then I'm going to put it back up here. So let's see. Y equals minus 4 over 9x plus 4. Now, we need to get this x term onto the other side of the equation. So let's add that since it's negative. We're going to add it to both sides. And that gives me 4/9 x plus y equals 4. But I can't keep this a fraction, can I? I need to make this into a whole number. And to do that, I multiply the entire equation by this number here, the denominator. So, by the denominator, yeah, by 9. So, let's distribute. This is going to be 36. I'm going to do it backwards. 9 times y, that's going to be 9y. 9 times 4, well, the reason we multiply by the denominator is because we can just cancel out the bottom. These two cancel. So that leaves us with just what's on top, which is 4. So there's our equation. I'm going to put it back up here. 4x plus 9y equals 36. All right, I'm going to erase all of this. Let's see, 4x plus 9y equals 36. There it is right there. It might be A. 4x plus 9y. Nope, it's not B. 9x. No, x was with 4, so it's not C. 9x plus 4y equals 13. No, hey, looky there. We didn't even have to do anything else. But just to be sure, let's see. The other equation is this. 3x minus y equals 2. Let's put this into slope-intercept form by subtracting 3x. Move that x back over to the other side. Minus y equals minus 3x plus 2. And then just change all the signs. There we go. Y equals 3x minus 2. Here's minus 2. That's the b value. Yep. 0, 2. Oh, minus 2. That's the b value there. And the slope should be 3. I'm sure it is. Let's see. Let's go 1, 2, 3, and over 1. Yep. 1, 2, 3, and over 1. Yeah. 1, 2, 3, and over 1. There we go. Slope is 3. All right. It is A. Nice. Let's do these last few. Let's see. Which graph best represents the system of equations and it is solution? Oh, why did this? That is not necessary. Okay, which graph best represents the system of equations? Well, let's see. These are in standard form, and all of these graphs, what's the best thing we can see about them? Well, we can see their intercepts. This has a y-intercept of about a half. This has a y-intercept of -4. And it looks like they both have x-intercepts at 2, 0. Let's see. Maybe that's 0, 1/2. And this is 0, -4. Well, we could go through and do all that, but here's what I'm getting at. Let's find the intercepts here. And the way you do that is, if you want to find the x-intercept, then you set y equal to 0. And if y is 0, then that means this whole term is 0. Because anything times 0 is 0. So that goes away. So now I just solve what's left. 8x equals -16. So 8x equals -16. I'm just going to divide by 8. And that gives me x equals -2. So the x-intercept here is -2. Okay, so one of these lines should have an x-intercept right here at -2. And this one doesn't, so it's not going to be that one. This one doesn't have an x-intercept at -2 either, so it's not going to be that one. B? They both have x-intercepts at -2. Don't they? Over here, D, no x-intercept at -2, so it's not D either. Look at that. We didn't have to do any more work other than just to find one of 4 possible intercepts that we could have chosen. So, there. Not a whole lot of work. That was easy. Let's look down here. What is the value of x in the solution to this system of equations? Well, to find the value of something is to solve for it. So let's solve for x. That means we're going to have to solve this system of equations. Let's use elimination, because you're going to be using that the most throughout your high school career. Which means we need to take this second equation. The top one's already in standard form, so I'm going to actually do this. I'm going to rewrite it. 3x minus 5y equals 22. It'll be in green, and I'll use orange down here for this one. But I am first going to add 5x to both sides. And that'll give me this. I'm going to write it over here. 5x plus y equals 32. So that gave us that zeroed out, and then you drop these down. So I'm going to get rid of that just to be nice. Room. Okay, so the second one is orange and the first one is green. Let's use this color and solve. What are we going to have to do? Well, let's see. We need the same coefficient, but different signs. Remember that. Same coefficient, different signs. That's what we need to find for elimination. So, well, 3 and 5, those aren't the same. They have the same signs. This right here, this is probably going to be easiest because we have a -5 on the top and a +1 on the bottom. And that means that we can just multiply the bottom by 5, and that'll give us a +5y on the bottom, which is the opposite of -5y. So let's distribute this. I'm going to rewrite the green one. We're going to draw another line, and that way we'll get a new system. 5y equals 22. Let's make the bottom one blue. So 5 times 5, that's 25x. 5 times y is a +5y. There. Calculate that. And then 5 times 32, I'm going to have to use my brain. 5 times 3 is 15. And that's in the 10, so that's 150. And then times 2, so 140. 140. All right, let's combine those. This goes to 0. So 25 plus 3, that is 28x equals 160. No, that's 162. All right, let's divide by 28. Divide by 28. And that cancels. So x is, let's see. I'm going to venture a guess and say 2, 3, 4, 5, 6, 7? 28 times 7 is, no? What times 8? 6? No. Here, let's find it. Look at me doing long division. 28 goes into 160. No, 3. Oh, 4. No, that's not right. That's 8. That's 11. 8. Oh, 9. 9 of them? Oh, yeah. No, that's too much. 6, 5, 4. Oh, we're gonna have some left over probably. Here, you know what? I could just use a calculator. I thought I could do it in my head, but I was trying to reason. All right, I'm pulling up my calculatory instrument. 162 divided by 28 equals what? Okay, well, that equals 81 over 14. Okay. That's a strange value. Did I do something wrong? No. Doesn't look like it. Okay, well, the value of x is 81/14, which is, let's see, 70, which is 70 11/14. Okay. Well, there's the value of x. It seems like a really weird number, but 3x minus 5x to 5x plus 1 is 32. Okay. Did I multiply that wrong? 5 times 32. 5 times 32 is 160. I sure did multiply it wrong. It's 160. Haha. Okay, so let's correct that. Look at me, a teacher making mistakes. That's 160. 5 times 32 is 160. So that means this is 182. And I bet this is going to be a whole number. Yes, that's going to be 182 divided by 28. 82 divided by 28. That is 6.5. X equals 6.5. There we go. I was going to say, no, the rest of us teachers would never let a weird number like that go. All right, let's do this last one and wrap it up for the night. Which graph best represents a system of equations that has no solution? Well, this is pretty easy. If it has no solution, well, the solution is where they cross, right? There's a solution. It's not that. Well, yeah, these cross at the origin, so that's not a solution. Hey, these don't cross, but they would if we kept on going out this way, wouldn't they? Yeah, they would cross out here, so that's not going to work. It's not going to be B. How do we know D is the answer, besides the fact that we eliminated all the rest? Oh, because these lines are going to be parallel. They're never going to cross. So we can put these little symbols on there. You'll learn that in geometry next year. Put a big triangle on there to show that they're parallel. All right, children, that is it for me. Hope you learned some new test-taking tricks with this. And I will see you next time. Goodbye.